Welcome to the Appendix lecture for Session 2. Like I said in the email, this is a presentation just to give you access to the lecture on facets. As you watch this, since we can't discuss it in real time, be sure to jot down notes or any questions or observations you have. And we'll take some class time to share about these during Session 3. If you want to follow along and type notes onto your saved copies of the PowerPoint slides, you can leave this YouTube audio running in the background and open the PowerPoint file on your computer and follow along there. We're starting with slide number 24 from Session 2. So, when we left off, we were discussing hierarchies, especially the differences between monohierarchies and polyhierarchies. Remember, the only difference between a monohierarchy and a polyhierarchy is that in a monohierarchy, any given child can only have one parent. It doesn't matter how far down in the hierarchy it is. Looking at this slide, we see that the housewares hierarchy at the second bullet level is showing 3 levels. The child nodes are the concepts or items at the second and third levels. The items at the second level of the hierarchy are children of the items at the first level of the hierarchy. The items at the third level of the hierarchy are children of the items at the second level. I just want to make sure that you understand that children can be at any hierarchical level except, by definition, the top level. So that means that an item in a hierarchy can be a parent and a child at the same time, like the categories in the housewares hierarchy here of appliances and bedding. Each of those is a child of housewares, and each is a parent of their own children. So again, a child in a monohierarchy can only have one parent, but a child in a polyhierarchy may have one or more parents. That's not to say that they do have multiple parents. In reality, many polyhierarchies only have a minority of items that have multiple parents. But the difference is in the rules of the hierarchy. A monohierarchy requires that a child only have one parent, and this usually has a functional reason, like we mentioned the physical arrangement of items, if an item can only be in one place at a time. Let's think about our grade school curriculum that we talked about in class. Each course is the treatment of a certain subject taught at a certain grade level. So chemistry has the subject of science and the grade level of 10th grade. But let's say that in the school office, they need to organize paper files of each class's attendance records. It doesn't make sense to have a paper filing system that honors both aspects of the course, so they're going to have to pick one. Since the faculty at the school is organized more by subject than by grade level, the office decided to organize their files by subject. So chemistry rosters will be filed in with science classes, disregarding the fact that chemistry is a 10th grade class. They could just as easily have done it the other way, but they had to choose one. Another example of a monohierarchy on this slide is the table of contents for a book. Clearly, most books you would read won't repeat content in separate sections of the book. If there's a book about, say, fitness and nutrition, there might be a section about the importance of good sleep for metabolism. This section could go into a chapter that emphasizes fitness or into one that emphasizes nutrition, because metabolism has to do with both. But now that what the author could do is put the metabolism section in the fitness chapter. Let's say that one comes first in the book. Then later in the nutrition chapter, there can be a reference back to the metabolism section in the previous chapter. But again, there's only one system of organization going on there, or only one location that the metabolism section can have. Now, like we said, polyhierarchies allow for, but don't require, a child item or concept to have multiple parents. Back to the chemistry class. If those attendance rosters that the office is keeping were digitized, like spreadsheets, then the school office could link to the same file from 2 or 3 different places. There could be a subjects folder that has subfolders for science, social studies, English, and so on. There could also be a grade levels folder that had subfolders for 9th, 10th, 11th, and 12th grades. There could even be a teacher's folder with subfolders for each teacher. Each of these folders could have a shortcut to the spreadsheet that has attendance records for Mrs. Molecule's 10th grade chemistry class. And note that you would want these to be shortcuts to one file so that changes can only be made to one file with the data being accessible and up to date from all of the folders. Another example of a polyhierarchy might be a tour guide at the zoo. So let's say you're at the National Zoo with your kid or your nephew, and you're trying to decide what to do next. Depending on your needs, you might want specifically to find the lions. So you would want to see a list of animals by their categories, like big cats, reptiles, primates. So you would want to look under big cats to find the lions. But next to you is a grandmother who wants to take her grandson to whichever animals are nearby because they don't want to hike up that huge hill at the National Zoo. So she wants to see a list of animals within 20 yards of her current location. The lions fit into that category. They're right across the way. Oh, and over here is a daycare group who wants to see some animals get fed. So the chaperones want to find animals that get fed between 3 and 4 p.m. It just so happens that the lions fall into that category as well. So a zoo app on a tablet or phone could allow visitors to navigate the zoo using any of those avenues. The underlying organization of the information is a polyhierarchy. It allows for the exhibits at the zoo to be organized by animal category, by location, and by feeding time. Each exhibit would be a child of a parent from all three of those facets. So those zoo categories are facets. What are facets anyway? So facets are dimensions of characteristics of an entity. Like with the zoo app, the entities are animal exhibits, and the facets we discussed were animal type, location, and feeding time. They are mutually exclusive, and what I mean by that is that if we made a list of the categories for each facet, not the items in the facet, but those mid-level categories that can be used to organize the items in a facet, the same category would not show up twice in two different facets. So let's look at the kinds of mid-level categories that would go in the zoo example on the next slide. Now this slide is not in your notes. We would have just done this on the board in class, and I just typed it up real quick on a new slide. So we have our three facets as the top level of the hierarchy for the zoo application. Within each facet, there are those mid-level categories that we can use to organize the individual items, which are the animals themselves. You can certainly have more than one mid-level, but what we're emphasizing here is that the top level of these are mutually exclusive dimensions or characteristics of the focal entities we are trying to organize. In this case, our focal entities are zoo animals. Focal entities could be shoes, plants, foods, concepts or topics, classes or courses. They can be anything that one would classify or organize. Now that that mutually exclusive aspect of the definition means that the kinds of organizational concepts that can go into each facet will be unique to that facet. So in the animal types facet, we see very different labels, very different kinds of concepts than we see under the feeding times facets. One shows animal categories and one shows times of day. You can't commingle these concepts in a way that would make any sense. And that gets us to another aspect of the definition for the next slide. The third bullet says that facets are in non-hierarchical relationships with each other. There is no hierarchical relationship between location and feeding time. Now, lions have hierarchical relationships with locations, and lions have hierarchical relationships with feeding times, but locations and feeding times are separate dimensions. They do not relate to each other. And this brings us to facet analysis. Facet analysis is the process of identifying the facets that characterize a domain. If your task is to organize information or organize resources, and you have the flexibility of using facets, then early in your process, you need to decide what the facets are that should be used to organize the resources. Then, once you've identified the facets, you'll come up with the categories that flesh out each facet. This is the vocabulary for each facet. So with the animal types, the vocabulary consisted of the names of the different sections of the zoo, like big cats, primates, and reptiles. Let's take a look at another example on the next slide.